In this video, we'll be finding the limit of this. So first thing we want to do is relate this to the definition of derivative, which is f prime of a is equal to the limit as x approaches a, f of x minus f of a over x minus a. Here f of x will take the role of the tangent cubed square root of x plus pi squared over 16. But we want to make sure that f of 0 is 1. Okay, so we want to make sure that this is in the correct form. So plug in x equals 0. You have tangent cubed of square root of pi squared over 16. Taking the square root of pi squared over 16 is pi over 4. We know that tangent of pi over 4 is 1. So you can think of tangent cubed pi over 4 as just tangent pi over 4 cubed, which is 1 cubed, and that's 1. Okay, so that is good. So it's f of x minus f of 0, and the denominator is x minus 0. So that's perfect. So now we can use this shortcut, and really all it comes down to is finding the derivative at x equals 0. But now the hard part is actually finding the derivative, because you have to use the chain rule a bunch of times. So what I like to do here is put the 3 outside here, because we're going to cube tangent, right? So tangent cubed, the cube will be outside. That'll be like your outside function. And I'm going to rewrite the square root as raising it to the 1/2 power. And that's only going to be the x plus pi squared over 16. So I want to make a note that this does not equal tangent of x plus pi squared over 16 to the 3/2 power. This is wrong. So don't fall for that mistake. Okay, so first the outside function is going to be the 3, the cube. Bring it down. Keep the entire inside the same. So whatever's inside the brackets, leave it alone. And then we're going to subtract 1 in the exponent. So from 3, it's going to go down to 2. Okay, next step. We have to work in the inside. Take the derivative of the inside. So for the inside, the outside function is tangent. Okay, so the derivative of tangent is secant squared. The inside will be the rest, the square root of x plus pi squared over 16. Next, take the derivative of the inside. Well, first there's the outside function, 1/2. Bring it down, keep the inside the same, so x plus pi squared over 16 is the same. Subtract 1 in the exponent. 1/2 minus 1 is negative 1/2. Take the derivative of the inside, which is just 1. Now simplify. If I plug in x equals 0, we know wherever there's an x, just get rid of it. That's all I did in this step. Okay, next we're going to simplify this further. Notice that I have 3 of these. Basically 3 of them. Pi squared over 16 to the 1/2 power. That's just the square root of pi squared over 16, which is pi over 4. But here there's a negative. So when there's a negative, you flip it. It becomes 4 over pi. And really, I should put a bracket here showing you that you're not multiplying that. Okay, so it's secant squared pi over 4, and then multiplied by 4 over pi. Now this 2 goes on the bottom here, 3. So that's where you get 3 over 2. And yeah, that's it for that step. And now tangent of pi over 4 is 1. Square that is 2. I'm sorry, square that is 1. So that's where we get 3/2. 3/2 times 1. So this whole thing is 1. Secant squared of pi over 4 is 2. And to show you why, start with cosine. You can write it as 1 over root 2 or root 2 over 2. Let's keep 1 over root 2 because that's easier. Because that's just root 2. And then square that. You get 2. But if you want, you could just show that it's 2 using the root 2 over 2. Okay, so that's 2. And then obviously keep the 4 over pi the same. Now, these 2's are going to cancel, and you have 3 times 4 is 12, and pi in the denominator. So the answer to this limit will be 12 over pi.